All right. Hey, Flavio, thank you. I appreciate the opportunity to be here. And thanks for the opportunity for everybody to give a discussion on WPA3 and advancements in wireless security. If there's any questions, please communicate them, and then we'll try to answer them along the way. So just real quick, want to start out. This is a discussion on WPA3. So again, what we can I'll go in and out of a little bit what WPA3 is, where we're going with it. But what I want to make sure everybody's aware. So one of the cool things about my day job is at Cisco, I get to actually chair the Wi-Fi Alliance Security Working Group. But today, for everybody, I'll give you some insights, but it's not as the chair of the Wi-Fi Alliance Security Technical or Marketing Group. It's just as a mild-mannered Cisco employee and engineer. So again, much appreciated the opportunity to be able to talk to everybody. So, I kind of look at security, especially Wi-Fi security, in a couple different lenses. It's usually in this kind of path where, security's interest, whether it's from implementers, technologists, or the industry, is based on your last security incident. So what ends up happening is, you start, if there's no attacks, everybody's secure, everybody feels secure. Nothing happens, no interest, an attack gets published, and then the media hype cycle begins. Once the media hype cycle begins, there's a whole flurry of stuff that happens. And then after the patches are deployed, everybody's kind of back to normal. And really, security kind of goes to the wayside. I spend most of my time in the center, really kind of in between dealing with security patches and trying to help usher forth new technologies. So part of it, and for those that aren't aware, WPA3, which is our latest version of Wi-Fi protected access, is now mandatory as of July 1st, 2020. So this is actually a great thing because we haven't seen a lot of advancements in Wi-Fi security in probably at least the last 10 years. So now we have a great new starting point, and we'll really talk about in a minute what that means. So and it's taken at least 5 years, if not longer, to get WPA3 out the door from start to finish. There's a lot of work, a lot of companies behind the scenes working on this. So what I like to say is, for those that are old, as I am, the way I view the road to Wi-Fi protected access is you have the IETF, the IEEE, and then you've got the Wi-Fi Alliance, which brings, those specifications to the table, and we looking to make modifications, and we try to put out a certification. My role as the chair is I usually feel like the robot in blue, where I'm trying to get everybody marshaled forward, and it's all about compromise, right? We bring everybody together. We try to work out what's best for the end users, get that pushed forward in a timely fashion, and get it out to the end users to be consumed by the public. So if you look at the history of the Wi-Fi Alliance security program, right, we first started in 2001 with WEP, and then WPA shortly followed once WEP was proven to be less than secure. So that was 2003. WPA2 came out in 2004. And then there was this real big lull in what happened in the security industry. So from Wi-Fi, not a lot of stuff was done. You had WPS that came out. Wasn't really considered security. It was more how to easily onboard. But then things started in 2017 when crack came along. So we had crack, and then we had a release for WPA2 security enhancements. And then WPA3 came out in 2018. We actually did a launch of WPA3 in 2018. It didn't become mandatory until, as I said, July of this year. At the same time we launched WPA3, we launched Enhanced Open, which I'll talk about as well, and really what Enhanced Open brings to the table. But then in 2019, we saw Dragonblood, which was some vulnerabilities discussions on what we launched as WPA3. So we did some patches. Again, the good thing about what we're doing with WPA3 today is it's continuous security improvements. It's not a stale program where you do it once and then we walk away and don't do anything until there's a vulnerability. So what most people aren't aware is that since WPA3 is evolving, we've released new features in December of 2019, and we have some new features coming in December of this year, 2020. So I'll give everybody a preview of what's to come in December of 2020. So that's when certifications start. You'll start to see those products coming out from all different vendors in in probably January, February of 2020. Again, when I talk about the Wi-Fi Alliance, there's a mix of great vendors. This isn't just a Cisco thing. There are a number of vendors that participate in security. And the cool thing about my job is it's a great effort, and I've got an opportunity to work with a lot of great people from various companies that are passionate about wireless security. So on the topic of enhanced open, right? So what is enhanced open? And I have a little asterisk, call it not quite WPA3. This is really how did we address the issues with open networks? So open networks, the problem that we're trying to solve, right? Passive eavesdropping. That is the only problem we're trying to solve, right? So it's better than an open network, but we don't really deem it as security. Security usually has two aspects: authentication and then confidentiality and privacy. With this, we're not necessarily really providing that authentication piece. We're just providing the privacy piece. So it's an unauthenticated encryption method. It's based on an RFC for OWE. And what we did is we brought it into the Wi-Fi Alliance and we branded it, because every program pretty much gets a brand. It's branded as enhanced open. So we don't claim man-in-the-middle prevention. We don't claim anything other than it being a enhancement to open, where we're providing unauthenticated encryption and at least allowing or mitigating that passive eavesdropping. For those techies in the audience, I did drop in some information on basically sniffer traces. So, the key thing is in here, we're using group ciphers of AES CCM 128 pairwise ciphers, but the key thing to look at if you are a techie is the AKM that we're using. So it's basically 18, which is OWE, and we're actually mandating management frame protection. So that's slightly different than what we've seen normally, right? So in an open network, we're typically not doing anything. This case, we're actually doing unauthenticated encryption, and we're also enabling management frame protection, so that once you're associated, we're trying to mitigate the possibility of anybody being subject to a deauth and then a man-in-the-middle attack. So part of the challenge that we had to come up with is when we implemented, during the initial implementations of OWE, or enhanced open, we actually saw some quirks that came out of already available stations or clients. What would happen is if you had a BSS that had enhanced open enabled on it, you would see some stations react to it as if it were a PSK network. Some stations would react to it if it was a .1x network. And some stations wouldn't recognize it at all and just let it go. So what we actually had to do is come up with a transition mode for this. So, again, one of the things I always say, and you'll see this mantra throughout any of my discussions, with regards to security, nothing ever good comes out of a transition mode, ever. It ends up being twice as much work. And when you have a transition mode, you're always going to be subject to the lowest common denomination of security. So again, it's just some mantra that I live by. When we look at what enhanced open transition mode actually is what we have is an open SSID. So we have a 2 SSID model. We have an open SSID and we have an enhanced open SSID. And think of them as being virtually linked together. Basically, what happens is in the open SSID, we actually advertise this OWE element that basically tells a station, hey, there's an OWE network, and we give it the BSSID and the SSID, again, in the open beacon frame. At the same time, on the enhanced open SSID, we advertise the open SSID. And the only reason we do this is so that if you come up and your client sees the open network first, it knows immediately that there's an enhanced open SSID it can connect to. So again, we tried to make it a little bit smoother, a little bit easier to get on these enhanced open networks, and also not disrupt current client install bases. So over time, as in new enhanced open clients come out, we hopefully will start to phase out these open SSIDs, and over time we'll be a little bit more secure at the onset. Onto WPA3, kind of what's the difference between WPA2 and WPA3? Again, first and foremost, when you look at it from a packet capture, there's no information element designation between WPA3 and WPA2. The IE looks the same. The difference is when we set out to do this, WPA3 is really defined by AKM, cipher suite, and management frame protection combinations, right? So we didn't come up with a new information element. It just didn't make sense at the time. Another benefit of the program, as I mentioned before, it's a continuous security development. We've had multiple features released since WPA3 was launched, and we're going to continue to develop new security features and capabilities under the WPA3 brand for the foreseeable future. One of the big changes that we implemented, everybody thinks the Wi-Fi Alliance is all about interoperability, which it is. One of the things that we did with security this time was we actually started adding conformance tests. These conformance tests basically make sure that nothing bad happens when stations or APs do something out of the ordinary. We want to make sure that the client and the APs are protected from getting a bad packet and then rebooting or having something unexpected happen. Again, PMF, anything designated as WPA3, PMF must be negotiated. It is not optional. You cannot have a WPA3 connection without PMF being negotiated. And the cool thing is for Wi-Fi 6 and forward, all new certifications have to be WPA3 by default now. So just to level set a little bit, there's a lot of terminology that gets tossed around in the security space. Modes are different than the brand, right? So we have different modes of operation. So we've got WPA3 personal, which everybody's pretty much aware of. But within that, we have two different modes of operation. We have WPA3 SAE mode, and then we have an SAE transition mode. SAE is really the authentication mechanism and key generation that sits underneath. And then transition mode is what allows us to be backward compatible to WPA2 PSK. So we've got those two operations, or those two modes that are under personal. And then we have enterprise. Enterprise is a little bit more complicated. So we have WPA3 enterprise only mode, which basically looks like WPA2 enterprise, except for PMF. PMF is required. Then we have WPA3 enterprise transition mode, which allows you to negotiate PMF. Okay, so if PMF is negotiated, a WPA2 connection would be enterprise connection would be considered enterprise or WPA3. If PMF is not negotiated, then it would be considered a WPA2 enterprise connection. And then we have this new thing called WPA3 enterprise 192-bit mode. The original discussion, everybody thought it was developed for the federal government. It's really not. It's more of a consistent cryptographic approach to security. There's a lot of things that go into, AKM selection, cipher suite selection, PMF, even if you take it up a level, the EAP types that you're using. So one of the things that we did here is 192-bit mode means you're guaranteed 192 bits of cryptographic security end to end from the Wi-Fi layer to the EAP methods that you're using to provide that consistent cryptographic mode of 192 bits. And 192 bits, where does that come from? Basically, if you look at the cryptographic strength of each of the pieces involved, SHA-384, which is one of the mechanisms we use, SHA-384 is actually 192 bits. So that's where that's our lowest common denominator. Again, a quick packet capture just to show everybody, again, for those that need some bedtime reading. Again, group ciphers with WPA3 personal only mode. This is not a transition mode. You only see your AKM, which is SAE of 000FAC8. That designates that this is a SAE or WPA3 personal only, and PMF is set to required, which means it is not negotiated. If you try to select an AKM of 8 and PMF is not set to required, the station will not be able to associate. In the transition mode, you can actually have multiple AKMs within the transition mode. So you can have WPA2 PSK, WPA2 PSK with SHA-256, and then SAE. Depending upon which one of those AKMs you negotiate determines the mode you're in. So again, if I negotiate and I come in as an SAE, PMF must be negotiated. And then if I don't, I can either do WPA2 PSK, either modes of PSK. When we look at the transition mode, why did we do this, right? And I always kind of poke a little bit of fun at this. It's like, wait, all APs support WPA3, support multiple BSSs, right? Transition modes are really created to preserve interoperability with WPA2. However, the key thing is what you inherit from transition mode is, because it's a single BSS and you're using the same passphrase for WPA2 PSK and WPA3 personal, because that same passphrase exists, you have the vulnerabilities that existed in WPA2. And also, the key point is, if I with that passphrase, I'm not only giving them access to the RF side, I'm giving them access to the physical network. So those are some things to keep in mind. Again, WPA3 personal sessions themselves will still be secure, different than WPA2 PSK. But again, you're giving away access to the physical network. And again, my mantra: nothing ever good comes from transition modes. You can get yourself into some downgrade scenarios where in these BSSs, you could attempt to connect at WPA3 PSK. Somebody could jump in as a man in the middle and downgrade you to WPA2 PSK. But have no fear, we've got some solutions for that coming out in the latest version of WPA3. When I look at WPA3 Enterprise 192, WPA3 Enterprise 192, again, just as a quick overview, is the same thing that you've seen before, except for this time our AKM is 12, which is signaling SHA-384. Our group ciphers and pairwise ciphers immediately switch to AES GCMP 256. And again, management frame protection is required, and we shift to GMAC 256 for the group management cipher suite. Again, this gets us to our 192 bits of security. What I didn't take a capture of is WPA3 Enterprise 192 uses EAP TLS. That TLS cipher suite that needs to get negotiated across that for authentication is also using a similar set of cipher suites set at 192 bits of security. So with all this said, what do we have here? We have all this information that I've given you is all in these cool links. If you've never been to the Wi-Fi Alliance website and you're interested in security, all of these things are out there for everybody to take a look at. There's the WPA3 tech specs are available. The WPA3 security addendums are there. Security considerations. And then we have this cool web page now called the security development page. It allows you to get a sneak peek into what we're working on currently for security, and you can provide feedback. So I encourage everybody, go take a look to see what's going on there. We're trying to be as transparent as possible as we're working on new security things. So let's talk about WPA3, the update that came in 2019, right? So we kind of know what came in WPA3. It's been around since 2018. This 2019 update kind of slid in. It didn't get a lot of press. Most people weren't aware of what's going on. Flavio, you have a question for me?
Yeah.
Go ahead.
Maybe this is a good time to interrupt you before you move on.
Yeah, absolutely.
Yeah. All right. So we have a couple of questions here. So first of all is what is the client support looks like so far? Because we are getting some infrastructure products, APs getting certified. Any comments about how the whole industry is evolving in terms of client support? Because that was one of the issues before, right?
Yeah, no, absolutely great question. So as a matter of fact, I was just on a Wi-Fi Alliance call before this. The latest number is there are 800 certifications for enhanced open today. So there's, whether it's silicon vendors, client vendors, you can go out to the Wi-Fi Alliance website and check the vendors that are supporting enhanced open. And the support for WPA3, it's in pretty much all major vendors, right? Client vendors right now. So whether it's WPA3 personal, WPA3 enterprise, again, if you go out to their website, you can get the specific numbers, but most of the major operating systems that I'm using now, there's WPA3 support.
No, great. And this is a good segue for another one. So when you mentioned the different modes of WPA3, which modes are needed for a client or for an infrastructure AP to get certified? Is it all of them? Is just personal?
Nope.
How that
Let
works?
me actually go back. I'll step back real quick for you, and we can walk through the modes real quick. So in a normal certification, to answer the question, the only mandatory certification for a Wi-Fi device is typically personal. So it used to be WPA2 personal was the bar, and then WPA2 enterprise was optional. We followed the same model. So WPA3 personal is mandatory, WPA3 enterprise. All of the enterprise modes are actually optional certifications. So if you go out to the Wi-Fi Alliance, you can look up a vendor and look up all the different modes, that they're certified for, whether it's personal or enterprise.
Excellent. Regarding WPA3 Enterprise 192, do you see that? You mentioned this initially was thought just for federal government. Do you believe that enterprise companies in general will going to get will adopt that? Or do you see anything that you'll probably restrict? You're going to need special clients? How do you see that? What is the expectation?
So it's interesting. From my perspective, I've actually been contacted by non-government customers wanting to deploy WPA3 Enterprise 192. It hasn't necessarily been a government only certification. Any customer that, if you're deploying an EAP method today, like EAP TLS, and you just want an additional level of security, again, when you look at WPA3 Enterprise, one of the shifts that we did was to elliptic curve cryptography, and elliptic curve cryptography is much more efficient on lower powered devices, and you can get higher cryptographic strength for less cost. So a lot of people have been looking at that as they move their certificate servers, their CAs, as they move their CAs to supporting elliptic curve certs. They've been pushing those down, and it's just been a natural fit. And it's pretty much seamless if you've already got that infrastructure in place to just turning on the Enterprise 192.
I believe that this question that came from YouTube it's totally related to that, right? So if you believe like WPA3 with AES CCM 256 are going to be just a RFP checkbox, so I believe you answered that, right?
Using CCMP only. So look, you can mix and match things like AES 256 CCMP or GCMP. I haven't seen a lot of people that allow mixing and matching, and that's actually one of the reasons we created WPA3 Enterprise 192 was to eliminate the mixing and matching between cipher suites, AKMs, group management ciphers, etc. We wanted to make it as simple as possible because not everybody's a cryptographic expert, right? When they're configuring the wireless networks. So yeah, I mean, you could say CCMP, AES-256 CCM could be a checkbox item. Is it deployable? Yes, it's deployable. It just depends on the customer requirement. And I've seen GCMP, by the way, again, if you go back to looking at cryptographic properties, GCMP is also can be parallelized in processing, which means, again, from a low power device, it's a little bit more efficient on the processors. So it'll save a little bit more battery life.
Okay, cool. No, we have a couple of more questions, but I'm going to let you advance a little bit in your presentation, and then we come back later with more questions. Thank you.
Okay, sounds good, Flavio. Thanks. So on to 2019. So what happened in 2019? We actually wanted to focus a little bit more on, kind of post the initial WPA3 launch. We looked at focusing on fast BSS transition because we knew there were a couple programs that did fast transition. Again, important in the enterprise. And then something that was really important on the enterprise side, which is server certificate validation. Today, most places, the station or the client was only presenting its cert. It was not validating what it was getting back from the server. So we wanted to make sure that both the server and the client were being validated to ensure that connection. So what did we do with fast transition? So fast transition, for those of you, it's also called 802.11r. 802.11r has existed for a while. We just didn't have one program in the Wi-Fi Alliance that validated fast transition. So what we looked at was, one, making sure nothing broke between devices. It used to be in the voice spec for the Wi-Fi Alliance. We pulled it out and made it an optional program. So what we did is we tested WPA3 personal, transition mode, enterprise transition mode, and we did add tests in for WPA2 personal and enterprise, specifically for backward compatibility. So it is an optional certification. So again, when you look at the certification statements in the Wi-Fi Alliance, you'll see if people have certified for fast transition. One of the things that we actually did here is we actually created a preference order for AKMs. So if you have a BSS that has multiple AKMs on it, we wanted to make sure that it was picking the most secure or more secure AKMs before the least secure AKMs in this case. So if you look at what happens on the personal side, excuse me, we wanted you to do FT authentication using SAE first, then just SAE alone, then FT authentication using PSK, and then PSK using SHA-256, and then finally defaulting to PSK. So if all 5 of those ACAMs were being advertised on a BSS, you'd obviously start at 1 and try to negotiate your way down. The same thing for enterprise. With enterprise, we want the order is FT authentication using .1x with SHA-256, then authentication using 802.1x and SHA-256, and then just regular SHA-1. So again, just kind of providing some security order to being able to use FT. So I didn't go into detail on what we're doing, but basically with FT authentication or FT transition with the testing plan, we basically just have show roaming between 2 APs and make sure nothing breaks and the correct cipher suites and AKMs are negotiated. On server cert validation, again, this is kind of really behind the scene ones. Where we have stations performing server cert validation when using the following EAP types: EAP TTLS, TLS, PEEP, and PEEP v1, right? So anything that involves a TLS method. So in this case, the station's going to validate the radius server cert, trying to prevent evil twin attacks. And we're providing that policy in the certificate, and it's going to prevent users from inadvertently accepting trust in a server certificate from unknown networks. So again, this is something to help us keep the end user safe in an enterprise environment when they're authenticating against a radius server presents its server cert. We want to make sure it's a valid server cert. Now we had those. They were kind of I'll call them a silent update for WPA3. WPA3 2020, which is where I wanted to focus a little bit more on today. We've got a bunch of stuff that we're bringing to bear in WPA3 2020. So we have an update to SAE. Again, what we try to do is we try to follow the IEEE, what they're working on in the IEEE and the IETF. And then if there's nothing there, we actually try to do some innovation. So one of the IEEE enhancements that's coming in the next version, which is for like 802.11, I think it's 2020 or 2021, whenever RevMD gets rolled in, is SAE hash to element. We'll talk about it in a second. The Wi-Fi Alliance, we actually came up with a method called transition disabled indication. It's a way to disable transition mode in networks. Beacon protection and operating channel validation came out of, again, the IEEE work that's going on in RevMD. AP validation in public networks. This is a Wi-Fi Alliance mechanism, and where we're actually validating, working on validating APs. And this would be like your typical coffee shop or some other mechanism out that's not a home network. And then we call it client privacy here, but it's really MAC randomization. So what's coming in this December 2020 release is actually a pretty significant release for us. So we're actually extremely excited about it. So if you have access to 802.11 RevMD, you'll see that there's this new thing with SAE called hash to element. It's basically a new method to generate the password element used in SAE. And then once you generate that, you can generate these other password elements offline as opposed to having to do it actively. So this new hash to element, it's had review in a lot of the IETF forums around cryptographic best practices. So we've adopted this hash to element. Again, basically because it's a best practice and it's significantly more efficient than the previous hunting and pecking method. Again, it's a way to bring this stuff in and make it a little bit less complicated for vendors to implement, as well as a little bit more efficient. And basically, anytime we make something more efficient, it has a positive impact to battery life on the device. So from a hash to element perspective, so we have SAE. The original method was called hunting and pecking. This is called hash to element. We basically advertise support of this with the RSN extension elements. So once the AP is configured, it'll actually advertise this out onto the RF network, letting the stations know which method to use. If a station doesn't support hash to element, it's absolutely fine to fall back to hunting and pecking. So again, this is more of a behind the scenes, but we wanted to let everybody know, hey, look, we're the Wi-Fi Alliance with WPA3. As standards evolve and things move forward, we're trying to embrace them as quickly as possible. And this came in, as I said, in RevMD as a work in progress. So we picked it up and figured we'd bring it into the 2020 release. Two of the other big problems that we've addressed are, when you look at where challenges may happen in the Wi-Fi space, is during beacons, which are typically unprotected, and then operating channel, right? Both of these typically today are opportunities for man-in-the-middle attacks or client redirection. So again, these are two new capabilities coming out in the next version of the 802.11 spec. So one is beacon protection. So we now actually can validate the beacon frames being sent to a station. This way it keeps us, again, if you look at the way we build our security architecture, we've got beacon protection that's going to be enabled. We have PMF that's enabled. And now this other feature called OCV, or operating channel validation. Again, these are all things that are operating at the same time to keep the station from receiving frames coming in from man-in-the-middle, evil twin, rogues, what have you, to have the station move off of valid AP. So we're doing beacon protection, and then operating channel validation is channel switch announcements. So we're actually protecting channel switch announcements such that in a man-in-the-middle, I can typically send a beacon that has a new operating channel in it, and the station will hear that, switch to the new channel, which a rogue AP or a man-in-the-middle evil twin could be on a different channel. So with operating channel validation, we're actually validating that and protecting that so that the stations don't switch. So again, the way I look at it is we're trying to functionally mitigate problems at different layers in the RF stack. And, again, it's kind of like building a castle. We're working at it a little bit at a time so we don't change everything all at once. So these are the latest two that we're tackling that'll be coming out. And then there's this function we came up with called transition disable mode. One of the things that was pointed out in Dragon Blood when that paper came out was downgrade attacks. Downgrade meaning if I have a transition mode, whether it's WPA2 transition into WPA, WPA3 to WPA2, if I had a man-in-the-middle or injected a frame, I could force stations to downgrade their security to the next lowest security. So in order to do this, what we did is we came out with this transition disabled indication, again, which will be coming out. And what it basically says is for your profile, when it receives a transition disable indication from a AP or controller, it will disable the transition algorithms for that profile. So if I have a profile that's WPA3 personal, and I get this transition disable indicator from the network, I immediately disable the transition algorithms on the right. So I disable everything other than the AKMs for SAE. SAE PK, we'll talk about that in a second. That's the actual working, the technical aspect of AP validation in public networks. We also have WPA3 Enterprise and then Enhanced Open. So what we're doing is we're trying to mitigate any potential for downgrade attacks coming from evil twins, man-in-the-middle, what have you. The next feature that we have is AP validation in public networks. So the real question becomes, how as a station do I validate against a public AP and make sure that the password I get is correct and that I'm not being brought on to an evil twin? So what we looked at is how do we enable a station to get information and encode it in the password to make sure that we are not connecting to this evil twin. So the how of it is we came up with this mechanism called SAE PK, which is based off of SAE. It's an extension. PK stands for public key. Basically, when the AP sends its SAE confirm message to the station, the AP also includes its public key, a modifier value, and a digital signature. So basically, we kind of combine all this together, and the station can then verify the AP's public key using the fingerprint encoded in the password. So this new password, depending upon the security strength, that's being used, it'll have at a minimum, basically 3 sets of 4 digits or characters separated by dashes, and inside that encoded is basically the fingerprint of that AP. So we're actually encoding this fingerprint such that if I type in the correct password, the AP validates that and we can get on the network. So it allows us to trust what we're receiving from the AP. So again, so that it's not associating to this potential evil twin. If the station fails to trust the received AP public key or fails to verify the digital signature, authentication doesn't occur and the station doesn't attach to the network. So the final feature that we looked at was the ever-growing concern around MAC randomization and what's going on with personally identifiable information. MAC addresses, again, on the wired side, MAC addresses were considered permanent. They were considered globally unique, which isn't necessarily bad on the wired side. On the wireless side, having a globally unique MAC address allows tracking, which, give or take, is a difficult thing and is very scenario dependent, right, on when you want to be able to expose that MAC address. So what we looked at was what was going on in 802.11. Again, there were some enhancements in RevMD. So we tried to look at that and figure out if we can construct some rules around MAC address randomization, again, to make sure that vendors are all doing the same thing consistently. And again, try to enhance some client privacy and make sure that we're not spilling out too much information into the RF network. So what are randomized MAC addresses? Again, basically the rules that we have is that a station is going to construct a uniquely randomized MAC address per SSID. That's in the profile, right? Unless the Save Wi-Fi network says not to do this and use a unique MAC address. And this randomized MAC address can be done per SSID at the discretion of the actual station. So we don't have a specific time limit. If a randomized MAC address is created for an SSID, it can use that permanently, that randomized MAC. Every 24 hours, it could generate a new MAC address. We didn't put any constraints on when that MAC address gets refreshed or gets changed. The other two pieces that we added in here is during active scanning. So if you've got your phone on and the Wi-Fi interface is on, as you're walking around, as it's scanning networks and it's not associated to a BSS, every time it sends out a scan, it's going to use a randomized MAC address for those scans. The same thing happens when you're using ANQP, which is typically associated with hotspot. Anytime for an ANQP exchange while not associated to a BSS, you'll also randomize your MAC address. Again, this is giving us some protections in the sense where if I'm not connected to, say, like I walk into a store, if I'm not explicitly connected to that store's network, they're not going to be able to track my MAC address and see that I come into that store every 3 or 4 days, that my MAC address every time I walk through that store, if I'm not connected to the network, is going to be randomized. Now, having said this, what's the challenge? There's always a challenge somewhere in here. With privacy and network operations, there's always a delicate balance. The impacts of randomized MAC addresses are just being investigated on the enterprise, whether it's home use or enterprise use or hotspot. So there are multiple use cases we have for wireless. The exact impact of these randomized MAC addresses are still being figured out today. I will say, after having been around in the industry for a while, randomized MACs have similar challenges to IPv6 privacy addresses. We did this years ago with IPv6 with doing privacy addresses, and what we found out was it was very hard to apply policy to devices that had randomly generated IP addresses. So constructing an access list or anything around that was extremely difficult. So we'll start to see the same thing happen around randomized MAC addresses, being able to associate a MAC address to a user, a MAC address to a policy. Again, that becomes less definitive. So we need to now look at, okay, if a MAC address is randomized, what's the new identity for that device or user? And there's work going on in the IEEE, the IETF today to look at the impacts and what we may be able to do in the future. So when you look at a MAC address, for those of you who dig down into what MAC addresses look like, basically bit 1 is set to 1 for what they're calling locally administered addresses. So what that means, if you look at what the rules are, if I set bit 1 to 1, that means the first octet ends in a 2, a 6, an A, and an E. So if you go out to your favorite, access point, wireless controller, what have you today, if you pull up a list of the MAC addresses and you see 2, 6, A, and E as the first octet, you've got randomized MAC addresses on your network. So I will say with some of the operating system vendors, their latest updates, randomized MAC addresses are on and enabled by default. So you're going to start seeing them more and more pop up into your networks today. So again, not necessarily a bad thing, just something to be cognizant of as things start to change a little bit in your network as these devices come back on. So some options to deal with randomized MAC addresses. Again, when we say deal with them, it depends on your policy. You can use an MDM in the enterprise to push policy to a client, whether you want them enabled, whether you want them turned off. There's opportunities to notify end users that if they want to connect to your enterprise network, that they need to turn off randomized MAC addresses. You can configure APs to send out a MAC address policy requiring the station to use a global address. And then there's also the ability to use a AAA server to create policy that recognizes a locally administered MAC address. And you could do differentiated service based on whether the MAC address is randomized or not. So there's a couple different ways to look at it. Again, it's that delicate balance between network operations and privacy that we have to, kind of keep in the balance. And then just kind of transition to where we're going. So there's a lot of talk about 6 gigahertz. So everybody's heard of Wi-Fi 6E. There's also 60 gigahertz fixed for broadband and other different new bands coming out. So what we wanted to do is really kind of level set what things should happen in these new bands and frequencies, since they're relatively greenfields. So what we said finally is WPA3 is now the starting point for all these new MAC-PHY bands. So no WPA2, no WEP, no open networks. It will absolutely be WPA3 as the starting point. So WPA3 personal is going to be required. WPA3 enterprise 192 will be optional, but there will be no support for WPA2. We're going to eliminate open networks, and there's no transition modes, thankfully. So we're getting rid of transition modes for these new MAC-PHY bands. So again, it's a great start when you've got a green field to look at. And then kind of wrapping it up, for us, 2020 and beyond, this is more questions to everybody in your group, Flavio. What do we focus on next for security? What do we need to look at? Security is really an obscure technology. Nobody typically gets excited. Do we need better UX UIs to inform users, consistent crypto? We're trying to look probably 3 years out. Love to hear some feedback. Tell us, kind of like, how am I driving? What should we be doing differently? What could we be doing better? So, with that, I think we're wrapping up just about on time for you, Flavio. Is that correct?
Yeah, sure.
I'm trying to keep us on track for you. I don't want to be the one that's making you late.
No. So we do have a couple of questions here. I think the session clarified some of them.
Yeah.
But just to highlighting, we have one here from Yuri. It's in Portuguese, so gonna help you out. So it's pretty much about the topic that you mentioned in terms of privacy.
Yeah.
And on all these MAC randomization discussions. When you mentioned that there was a standard I took a note here, 811 AQ, and now it's part of the RevMD.
Yes.
How does that play? I mean, you guys are looking in WPA3 this December 2020 release as a way to put at a standard or make some recommendations, but in the end of the day, the vendors, the smartphones and the end devices manufacturers, they can do whatever they want to do, right? If a vendor wants to go one path, they can go.
Right.
So in the end of the day, how that plays? So we have WPA3, enhanced WPA3 enhancements, but how that plays together with the vendors?
Yeah, so that's an awesome question, right? I mean, at the end of the day, so everybody's aware, right? No vendor has to get Wi-Fi Alliance certified, right? It's something that it's a stamp of approval, right? That you're doing vendor interoperability, and most people have come to understand the logo that that's what it means. So what we're encouraging people to do, vendors, is, hey, go, if you want to make sure your MAC randomization works right and it works with infrastructure, go through the certification. So MAC randomization isn't specifically tied to WPA3. Any client can do it. From a certification perspective, we put it into the WPA3 program because what we're trying to do is not necessarily go back and make modifications to WPA2. It's WPA2 exists, it is what it is, and we're just moving WPA3 forward, trying to add all the new features there. Does that make sense? So I mean, the recommendations are there. We're encouraging vendors to follow it, and then we work with them as much as we can.
Great. No, understood. So another question that we have here is in terms of all these advancements of the December 2020 release. When do you believe this will be implemented by vendors? Because there's some awesome new features you mentioned about the beacon protection, that works together with management frame protection, DP validation for public networks. So this will be released in December 2020, and we'll start certified right away. Or how do you see market adopting these features?
So I would say that there's more. You'll see vendors adopt pretty soon. So what most people don't see with the Wi-Fi Alliance is as we ramp up to do a feature release or do a new certification release, vendors are working behind the scenes to be part of the test bed to test things out. So when the program launches, there'll be a number of vendors, immediately certified and on the list. And I'll give you an example, Enhanced Open. As I said, we were just talking about this today. In March of this year, we had roughly 400 devices certified for Enhanced Open. This month, we're up to 800. So we've doubled in a year for Enhanced Open. So you'll see it ramp up slowly. But, again, I would say the more the features apply to the overall security, the quicker they're going to get adopted. And this also comes, and when I talk to customers, if you ask for them and you put them in your RFPs and you want them on your networks, ask the vendors to support them. That is the best way to get the vendors to get out there, move, and adopt them as quickly as possible.
Excellent. Sure. So there's another one regarding IoT. So WPA3 in IoT devices. So do you think this will be implemented in, when they say IoT, I'm assuming, simpler devices with simpler, stacks, or there's anything in particular that has been taught in the WPA3 certification for this specific types of devices?
Yeah, we do take the IoT vendors into account, and we have a lot of IoT vendors that participate within the security working group. And in the Wi-Fi Alliance, there's also an IoT group. So they follow closely with what we're working on. So yeah, most of them are going, they're all going through WPA3 certification. At a minimum, they're going to do WPA3 personal, but a lot of them have approached the security team about doing WPA3 enterprise as well. So, and then part of it, there's another certification program, which is kind of parallel to WPA3. It's called Wi-Fi Easy Connect. Wi-Fi Easy Connect is actually think of it as a onboarding provisioning type mechanism for IoT and other devices. Wi-Fi Easy Connect also enables devices to get provisioned with WPA3 credentials. So again, we're targeting IoT devices and security from a couple different angles inside the Wi-Fi lines.
Excellent. All right, so there's another question here asking about possible impacts in terms of battery consumption. If we compare with clients with WPA2 versus WPA3, is it better or worse? Anything that we should pay attention for it, or going to be pretty much the same?
Yeah, so if you look at from a security perspective and what's going on in RF in general, right? So obviously Wi-Fi 6, 6E, there's a lot of mechanisms in there for saving battery life, just from the RF mechanisms alone. Add on top of that more efficient cryptography, more efficient use of certificates and other things. It actually will help increase your battery life and have less of an adverse impact on the battery as well. So, it's not, I can't point to any one single thing. It's more like all the pieces fall into place. And overall, when you move to Wi-Fi 6, you've got a lot of things working for you to help prolong battery life or be less impactful to the battery on these devices.
All right, excellent. I have one personal question here. I faced this in multiple customers before. For me, one of the good news of WPA3 certification is have management frame protection as a mandatory feature. Because I faced this in multiple customers before. They would like to have a whole network in Wi-Fi, but then when they realized, that a very easy attack could, deny of service the whole network, they stepped back, and we didn't have much MFP support so far, in my understanding. And then surprisingly, you said you're going to have new features like the beacon protection. I thought management frame protection was enough, but then we have to protect the management frames. But then you mentioned the beacon protection are going to be in this update as well. So anything, do you believe, obviously, as WPA3 has MFP as mandatory, that will help a lot in the adoption?
Yes. I'm sorry.
How do you see that? Yeah, how do you see that?
Yeah. So as I said, so PMF has been around for a while. The challenge that they had was when PMF came out, it was optional to turn on for WPA2. And when we saw a bunch of the threats that came out, a lot of it were from man in the middle, channel changes and other things after the device was already authenticated and associated to an AP. So by adding in management frame protection, it helps mitigate it. And then what we saw was other things that were on top, right? So again, beacon frames, operating channel validation. There were other avenues. It is possible for a client to do beacon protection without PMF or operating channel validation without PMF. Again, from a Wi-Fi alliance certification perspective, if it's WPA3, we have to have PMF enabled. But if you pick a vendor and they don't have, and they're not WPA3 certified, they can implement, however they'd like. Again, which is why looking at the logo, looking at the certifications that the device went through is really kind of the main way to make sure all the security features are in place.
Great. And I think we have a final question here. I think you mentioned a little bit about it, but how do you believe this transition to WPA3 are going to happen? With like a natural, any comments about how painful this will be? You mentioned about 11R, for instance.
Yeah, so
it was not easy. So,
yeah, so my personal opinion. So I transitioned, so my home network, right? I like to think I'm a little bit more than an average wireless home user. I transitioned my home network to WPA3, and I will share with you that it was non-disruptive to the devices I had in my house. So IoT devices, most of all my kids' devices, their Xboxes and all their other things. So it's a little bit easier than most people think. Whether it's using the transition mechanism, cutting over a separate SSID, it's all absolutely doable. and that's why we kind of moved it in the way we did, as opposed to being a hard cut. So that's why I always talk about it with customers as much as possible. You know, the real importance of having, you know, get WPA3 in as early as possible now.
Excellent, excellent. So, Stephen, I think, you know, the conversation was awesome. I also appreciate the participation of the people like Gerardo, Yuri, Anderson for all the questions. Really appreciate for taking the time. We learned a lot. So thanks. You're more than welcome to stay in the conference. We're going to be talking in Portuguese.
No,
any final comments from your side?
No, look, Flavio, I appreciate you and the folks here inviting me to share what we're working on from a security perspective. Love the conversation. It always concerns me because not a whole lot of people care about security anymore. It's like one of those things that we expect to be there. So if there's any questions, Flavio, you know how to reach me. Anybody, my email is on the slides. Do you want me to upload you the slide or get you the slides?
Yeah, sure.
Okay,
sure.
I'll drop them to you, and then you can share them around. If there's any questions anybody has, please feel free to reach out.
Excellent, excellent. Thanks. Really appreciate it.
Awesome.
Thank you.
Thanks, everybody. Appreciate it. Take care, guys.
Thank you.
Thank you. Bye.